go. Hello, Mr. Aaron, Mr. Ryan. You alright?
Yeah!
What's binary tree?
A binary tree, the binary tree that is a tree with number that blah blah blah.
Okay, binary tree is kind of graph, right? The tree.
Waffy.
Okay, so I'm going to write the binary tree here, and then can you tell me?
But it's the longest path.
Okay, so can you tell me that
What's the longest path?
which
That
one
we
is the
remember.
root? Which one is the root? Which one is the root? This is the binary tree.
It's free. Free.
Which one is the root?
0.
Yeah, 0. That's the root.
0.
Which one are the leaves?
2 and 1. No, 4, 8, 3, 5.
For these are the leaves with no kids. Yeah, leaves. Yeah. So if you look it upside down, yeah, upside down, this is the root. Yeah, the tree is growing downwards. Okay, and these have parents. These are parents. Yeah, and also the children of the root. Binary tree because each node has at most 2 kids. Right? Let's go binary tree. Okay. A binary tree is a graph, right? It's a graph. And specifically is directed a cyclic graph. Why is it directed? Because usually you can only visit the children from the parents. So basically there's an error here, right? Yeah, it's an error here. It's one connected. Okay, it's connected. So it means a single component is connected. Yeah, it's connected. It's not like this. This is not a tree. What's this?
Forest.
A forest, and it's a graph because look, it's separate. It's not connected.
It's 3 trees.
A cyclic, okay? It doesn't have any cycle. If I put another link here, it's not a tree, right? It has a form of cycle, okay? Yeah. So today's task is easy. We want to find out the longest. Okay, first of all, the longest even path. Longest even path. So 0 to 8, right? Or 0 to 4 is the longest. If I change this to say 4 and change this to 8, and the longest will be
0 to 8, 4.
so it could be coming from here or here, right? Okay, let's say I put another 0 here. So the longest will be 0, 8 to 0, 4, 8, right?
6.
Yeah, so that would be 6 nodes, right? So yeah, makes sense? So we have to step on the even numbers, yeah? Step on the even numbers. Yeah? Any idea how we doing this? Any idea? Any idea how we doing this?
We're doing
Think
it.
about it. It's
We're doing it by.
so what kind of algorithm can we use to traverse the binary tree? What kind of algorithm can we use to traverse
Breakfast search.
Breakfast search. Okay, well done. What's breakfast search order in this case?
0 to 4, 0 to 4, 4, 8, 3, 8, 0.
Okay, yeah, that's good. Level by level. What's breakfast search order? I mean, if it's let's say if it's what? If it's in order. You know the in order? Left, node, right. Okay, in order. So what's the sequence for the in order? In order. Okay, so in order actually, it's the other way. It's 4 to. Okay, so let's maybe do it pre-order. Node left to right. Okay, pre-order. Let's be
0, 2, 4, 8, 0, 4, 3, 8.
well done. Okay, no. Look, we visit the node first, so we go to the left tree and then we go to right tree. Look, yeah? Yeah. And for the left tree also, we go to the node first and the left tree, right tree. So it's a recursion, yeah? We can easily use the recursion to do the depth search. Okay, depending on which order we want. Okay. Okay, so look, we originally we want to find out the longest even path, right? Yeah. Okay, so how about if I telling you that DFS this function root, yeah, this root tells me the longest even path containing the root node, right? Okay, so DFS is 0. You tell me the longest root will be 4 because 0 to 8, 0, right? Okay, DFS root if we represent the longest even path containing this node onwards. Yeah? So how does that help us? How does that help us? How does that help us?
You can use that part,
Yeah.
Unless if it's all even, and
Yeah.
you can.
Okay, so yeah, quite close. Okay, quite close. Look, so how does this help us? Is that we can write the DFS search function, and then we can compute the path, the like longest path containing the node of this node, and it's even. Yeah, if it's even, we return we accumulate the path. Otherwise, if it's odd number, we return 0. Right? And by doing this the recursion, we can recall the left and right, right? Yeah. Okay, so look, this bit, yeah. Alright, this bit and this bit. This bit, the longest even number containing this node. Yeah, the longest even path number containing this node is DFS root dot left, right? Yeah, and this bit is DFS root dot right. Okay, okay. Then this is the number we just call it. Yeah. Okay, so if this is even number, right? Let's say this is L equals that, and this is R equals that. So if this is the even number, right? Listen to me carefully. If this is the even number, right? What's the longest? What's the even path containing this node?
Is that node and L and R?
That's right. L plus R plus 1, right? It will be the longest, right? Why is that? So look, the path, there can be only two situations, right? Why is that? It passing this node, or it doesn't pass this node, right? Make sense? Yeah? Look at the longest path of a tree. Longest path of a tree, right? It could be passing the node, or it could be not passing the root node. Okay, so if I want to pass this one, so root, it could be something like that, or it could be something like this, or something like this, right? Yeah. Okay, so I'm saying if this node is even, right? So the longest path, the root, okay, should be passing the root node, can contain this one, right? So it could be somewhere here, connecting here or here, right? Am I right? If this is odd number, right? Am I right? So I should not include this in the longest path, right? I should not include it in the longest path.
If it was 1, it wouldn't.
Yeah, so because it's even, it's odd number, so the longest path should not pass this root, right? So the longest path could be this or this, am I right?
The longest path is that one.
Am I right? Yes?
A depth search root left.
Okay, so makes sense. So the DFS function returning the longest even path, the node longest even path containing this node, the root node. Okay, yeah, okay. So let's quickly write this. Okay.
And then that's it for today.
And then you need to tell me think about how we getting this answer. Okay.
We're
Think about
getting this answer because we're so smart.
Ari, did you get it? Kind of, okay. Define, let's say longest even, okay. We are looking for even path.
Longest.
And then root, okay.
Odd.
Okay. So if not root, obviously return
0.
0. Special case. And then now we want to find the longest. Let's say answer. Okay, this is the answer, and the beginning is 0. And then we need to define the DFS search function, right? The root.
Define this is it.
If not root, again, look. If not root, return 0, right? Because look, this function will okay. So we would return the longest longest even passing root, okay? Remember, this is passing root. Yeah? Now, I need to do the air. I need to definitely search the root on left, okay? So this air is the longest pass, longest even pass on the left tree, right? Root on left. And then R equals what? Can you tell me?
Search root dot right.
Yeah, easy. Okay, now I have the left and right. Okay, look, air and right. Look here. Eric, look, I'm writing a tree here. Okay, so this is the root. Okay, this is the root. This is the root. Okay. Okay. Air root on left is this bit, right? This bit. This bit is air. Yeah. This bit is R. Yeah. Okay. So now, if this root, look, if root of value n1 equals 0, what does this mean?
If it is odd number, no even.
Even number. Remember the binary, yeah? 0, 1, 1, 0. What's next? 1, 1. What's next?
1, 0, 0.
And what's next?
1, 0, 1.
Okay, you got it, yeah? Look, if it's 1, it's odd number. If it's 0, it's even number. Okay, that's binary, yeah? Yeah. Okay, now if this node is even number, if this node is the even number, so look, the answer will be equals the maximum of answer. This is the answer. What? What's the look? If this is even number, what's the longest path?
The left and the right and root.
Plus 1, right? Right? Yeah? Yeah? If root of value, if it's even number, and then we should return what? We should return what? We should return what? We should return. Okay, so this function returns what? The longest even path passing the root, right? Okay. Okay, so now I want to return now. If this is even number, I want to return now. So what should I return? Which part is bigger? Yeah, I need to compare which this part is bigger, right? And then I need to plus 1, right? Yeah? Alright? Yeah, so return 1 plus maximum of air and right, okay? Yeah. If it's an odd number, I should return what? If it is odd number, what's the longest path, longest even path passing root? What's the number?
Nothing.
What's nothing?
0.
0, yeah, exactly.
Ooh.
Makes sense? Look, this is, yeah? Okay, so then look, we can do this depth search root. And then what should we return? What should we return?
Answer.
Answer. Okay. Look, there are two things in this recursion function. Can you tell me what are the two things this function does, the recursion function does? What are the two things? What's first thing? What's second thing? What's the first? What is this function doing here?
It is
What?
if it like
Sorry.
you
What's this function returning? That's the first thing. And what are we setting this answer here? That's the second thing. Okay, can you explain these two things? The function returns what value? What's the value?
0.
I know. What's it returning? What's this function?
Longest even passing root.
What does it mean? Can you explain in your own words? Okay. What does it mean?
It means it's the longest.
Okay, so if this here is 2, okay, then you tell me, okay?
Whoa.
Okay, so I'm DFS root here. So what does it return? What's this function return?
It returns
Which number? The path.
2.
Sorry? What's your number?
2. 5.
Why is it 5?
5.
Why is it 5? There are only 4 steps. Why is 5? The longest path. Which 5?
2, 4, 8, 10.
Okay, so how many notes?
4.
4 notes, okay, that's 4. Okay, so this is the longest path containing the even number, okay? Because look at here, if I put another one, 10, this is even, odd number, so it will stop here, right? Okay, so that's the first thing, yeah? If it's, okay, and how about this one is 1? What's this function returning?
3.
If this is, come on, what is 3?
0.
Why is it 0? Why you say,
3.
sorry?
Because 4, 8, 10. Yeah, I said 3.
No, that's the second thing. I'm saying that this function returning. Longest evens are passing. You see this passing here? You say it's passing. Okay, so if I DFS loot here, what's it return?
0.
0, because this is odd number.
0.
Okay, here, if you will come here, right? Okay, make sense? Yeah? What's the second thing it does here? What's the second thing? What's the second thing about answer? What's the answer?
0. It's
The second thing, if this is 1, the second, the longest path is the one you just said, which is what, Eric?
Is it?
The answer, I'm saying answer.
0.
What's the longest path containing the root? Not containing the root, everything. Here, 3, here, 4, 8, 10. You see, yeah, it's a little bit confusing, yeah? So that's two things this function does. First thing is this function returns directly the number of longest even nodes passing the loop, okay? But we're using this function to set the longest even path with or without passing the loop so far. Why is that? We set it here. This is the answer. You know, look, every time we find the even number, we set it, right? Yeah? Make sense? What's the time complexity? If you think about it, what's the time complexity for DFS search? What's the time complexity if there are n nodes here? What's the time complexity? We're done. What's the space complexity? We're done. Yeah, it's classic, the textbook, right? Okay, that's it for today. Bye bye.
Bye bye.